Okay, our next set of notes are titled Measuring Angles, Arcs, and Chords. Um, we've got our first vocabulary word here is a central angle, and it's an angle whose vertex is the center of a circle. Okay, so we've got the center here is a radius of BA is one of the sides of the angle, and another radius, AC, is another side of the angle. So we're going to write here that angle BAC is a central angle. Okay, named because the vertex of the angle is the center of a circle. So now we're going to talk about some arcs. So we've got a minor arc and a major arc, both labeled here on this diagram. A minor arc, you can see it's the smaller arc, so the arc is the part of the outside of the circle. So the minor arc is an arc that is less than 180 degrees. So 180 degrees would be halfway around the circle. All the way around is 360. So we're going to classify these arcs based on if they are less than half or if they're more than halfway around the circle. So the minor arc is from B to C. So a minor arc we name with 2 letters. So BC, and then we put an arc above them, is a minor arc. If our arc is more than halfway around a circle, we call that a major arc. A major arc, we are going to have to name with 3 letters, because if I say BC, I want to go the shortest distance in between them. BC does not mean going all the way around to connect those 2 letters. So if I want to name a major arc, I've got to include another letter for you to know which direction to go. So I'm going to call this one BDC, so you know it is a major arc. So major arcs we name with 3 letters. We've got the 2 endpoints and then 1 point that is in between them somewhere. So this is a major arc. All right, so we did if it was less than halfway around, and we did if it was more than halfway around. So now we're going to talk about if it is exactly halfway around a circle. That is what we call a semicircle. All right, so a semicircle is if the endpoints of the arc are actually the diameter. Okay, so there's 2 different ways that you can name this. You can choose the 2 letters. So we can say EG is a semicircle, or you can go ahead and use 3 letters if you want to. We can say EHG, or we can say GHE. Either one is going to be correct. So for a minor arc, we name it with 2 letters. For a major arc, we name it with 3 letters. And for a semicircle, you can choose which way you want to name it. So either one of these named is a semicircle. All right, so just to summarize what we were just talking about there with the naming, how do you name an arc? You name an arc by its endpoints. So where it starts and where it stops. What's the difference between this symbol and this symbol? Well, if we're just talking about this arc AB, this is just telling you what the name of the arc is. When you put an M in front, you're talking about the measure of that arc, which is what we're going to work on in example number 1. All right, so moving down to example number 1. We've got this diagram here in which we're told that we have some diameters. That's a really important piece of information because it's going to help us figure out what some of these angle measures are that we don't have listed already. So we've got RP is a diameter. So if RP is a diameter, it means this is 180 degrees, and so is this. So the first thing that I'm going to do is if RP is a diameter, it means that these three angles together should add to 180. So if I take 180 degrees and I subtract 64 and I subtract 42, what I'm going to get is a 74 for the angle TUS. Okay. If I take a look at the other diameter, which was QS, it means that these three angles together add to 180. So if I do 180 degrees and I subtract 74 and I subtract 64, it means that I'll get 42 degrees right there. Another thing that I could have done is I could have said that we had vertical angles right here. And I could have taken this 42 and written it here knowing that vertical angles are congruent. If I take a look at my diameter here, again, I know that these two angles also have to add to 180. So that would mean that this is 138 degrees. Okay, a central angle and its arc will have exactly the same measure. So that means if the angle whose vertex is right here at the center is 42 degrees, then this arc of SR will also be 42 degrees. So once I know each of these central angles, I can fill in all of the corresponding arcs to those central angles on the outside of my circle. All right, so right now I have all of my arcs measured and I have all of my angles measured and I've got all of them labeled appropriately. So now I can go to this list of these arcs and I can figure out if it's a major arc or a minor arc, and I can figure out what all its measures are. So we could actually go ahead and do the measures first if we wanted to, since we have all of them labeled already. If we said the measure of arc PQ, I did it already, it's right here. And since that's less than 180 degrees, that's a minor arc. ST is right here, 74 degrees. Also a minor arc. Then we get to TPS. So I'm going to have to go in the order of those letters. So I go from T to P, and then I keep going until I hit S. So what's going to happen here is I need to add up all of the arcs that I hit as I go around the circle. So 64 plus 42 plus 138 plus 42. And what I should get is 286 degrees. Since that's more than halfway around the circle, it's more than 180 degrees, this is a major arc. Let me erase that arc. And let's do another one. We've got RT. So this is two letters. That means I want the shortest distance between them. So here's R. The shortest distance to T is to go to the left. Okay, if I've got these two letters here, I want the shortest distance between them. So 74 and 42 together is going to be 116 degrees. That's less than 180 degrees, so that's a minor arc. Okay, I want you to pause the video right now, and I want you to try and fill in the rest of these on your own. All right, let's check your answers and see how you did. Okay, pause the video to check these if you need to. We're going to move on to example number 2. Example number 2 is really similar to what we did in example number 1, only I'm asking you less questions about it. But you're going to figure out your angle measures and your arc measures in the same way by knowing where your diameter is so that you can find out your angle measures. So what I see on this diagram here is I have this arc HG of 65 degrees. Since I have a central angle there, that means this angle will also be 65 degrees. And then I see I have vertical angles. And since vertical angles are congruent, it's also 65 degrees. And now I know that my diameter is DG. So that means together, these three angles add to 180. So if we do 180 minus 65 minus 52, we'll get 63 degrees here. And then if we do 180 degrees minus 65 degrees, this will be 115 degrees. So now that I have all the central angles marked, I can go ahead and mark all of the arcs with the same measures as the central angles. And once we have all of these pieces labeled, then it's easy to answer the questions A through C. So the first one, the measured angle GCH. So GCH, that's 65 degrees. The measure of arc FC, 52 degrees. The measure of arc EF, 63 degrees. Measure of arc DE, 65 degrees. DG, up to you whether you want to go over the top or if you want to go underneath. But either way, that's halfway around the circle. It's going to be 180 degrees. Measure of angle of arc GFD, D, then hit F, then D, also halfway around the circle is 180 degrees. Measure of angle GCH, right there, 150. And then the measure of arc DEH, so D, then hit E, then hit H. Yeah, so D, E, then H. You add all of those together, that will be 244 degrees. Okay, so that's quite a bit of practice with central angles and arcs having the exact same measure. All right, we've got a few postulates here to work on. Moving down here, what this first postulate is saying is actually what you were just working on in finding arcs that were made by adding two arcs together. So this is like arc addition. So the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. What that really is saying is that if we're taking this arc AB and we're adding it arc BC, then what we're really finding is the measure of arc ABC. All right, so that's what we just did when we were combining arcs in examples 1 and 2. Okay, so the next one, two minor arcs are congruent if and only if their corresponding chords are congruent. So it looks like I'm missing the diagram here. So I will fill one in for you, I guess. So what happens here is that we have a circle. And we're going to have two chords. And this will be A and C, and this is B. And what's happening here is we're saying that if the arc AB and the arc BC have the same measure, that's only because the chord AB and the chord BC had the same measure as well. So in order for those arcs to be congruent, the chords had to be congruent. So if you have congruent chords, then you'll also have congruent arcs. So I'll bring this down to these few examples to show you more about what that means. So in example number 3, I see that I have congruent chords being marked. A double mark right here. That means from A to C is 120. So from A to B should also be 120 degrees. If all the way around your circle is 360 degrees, you could find x by taking 260 and subtracting the two arcs that we've already labeled, which means what's left for x is also 120 degrees. And then to answer the other question, what's the measure of B, you would add together 120 and 120 to be 240 degrees. Okay, so that's using both properties above. It's using the property of congruent chords to give you congruent arcs, and it's also using the arc addition. Okay, let's do that again in example number 4. In example number 4, I have 2 arcs measured, and then I can see that I have 2 congruent arcs. So if I have 360 degrees, and I subtract 65 for that top arc, and I subtract 85 for that bottom arc, what's left would be 210 degrees. That's supposed to be split evenly between those 2 congruent arcs. So we're going to divide by 2, meaning that each one is 105. Okay, repeat that same thing on number 5. I've got congruent chords. That means these 2 arcs are also congruent. So if I have 360 and I subtract 116, that leaves me with 244 degrees. I have to split that evenly between these 2 arcs, meaning I have 122 degrees for each one. So the measure of arc AC is 122. Okay, moving down to number 6. Now we're looking at the measures on the chords. I see that the arcs are marked as congruent. So the endpoints between those make congruent chords. So 2x plus 4 is 18. Subtract 4. 2x will be 14. And divide by 2, we'll get a 7. All right, similarly in number 7, now instead of the expressions being on the chords, now the expressions are on the arcs. Because I see those congruencies here, it means those arcs are going to be congruent as well. So 3x plus 11 equals 2x plus 48. Subtract 2x from 3x, you'll get an x. Subtract 11, and you'll get that x is 37. So that takes care of the first part of this question. The next part says, what's the measure of arc CB? So that means I want this arc here. So I'll need to take that 37 and substitute it in to each of these 2 arcs to find out what they are first. So 2 times 37 plus 48 is going to be 122 degrees. Should be the exact same here, but let's double check. 3 times 37 plus 11 will be 122. So now I've got 360 minus 122 minus 122. That will give me the measure of arc CB, which will be 116. degrees. Okay, there is another page of notes here, but we're not going to do this page, which means that you're not going to do those questions on your homework either. So when you get to practice numbers 2 and 3, you want to avoid the questions that look like that. Okay, so for right now, we're going to stop, and then you're going to be able to do your practice number 1 based on just what this looks like. Okay, bye guys, hope you have a great day.